Solve the equation 6e to the minus x minus e to the x is equal to 1 for x belonging to a set of real numbers. So we've got 6e to the minus x minus e to the x as equal to 1. So the first thing to do is to write this thing here using a to the minus n is equal to 1 over a to the n. This becomes 6 over e to the x minus e to the x is equal to 1. Now what makes the equation difficult is that we are dividing by e to the x. So to remove that, what we're going to do is multiply the whole equation through by e to the x. So we've got 6e to the x times e to the x. So the e to the x will cancel out, so we're left with 6 minus e to the x squared is equal to 1 times e to the x, which is e to the x. Now this is actually a quadratic in e to the x. So rearranging this, we get e to the x squared by adding e to the x squared here, plus e to the x minus 6, and that's equal to 0. Now just one point of order here, that e to the x squared could be written as e to the 2x, okay? So let's just say again, note that e to the x all squared could be written as e to the 2x. So we have to solve the equation e to the x squared plus e to the x minus 6 is equal to 0. This is what's known as a disguised quadratic equation. So the normal procedure is let y be equal to e to the x. So we're going to have y squared, e to the x squared, so it's y squared, plus y minus 6 is equal to 0. Right, this is quite an easy quadratic to solve, so you can solve it by factorisation. Introduce a couple of brackets y and y, factors of 6 and 1 and 6 and 2 and 3. I would suggest it's going to be like a 3, a plus 3 and a minus 2. So you really at this level should be able to factorise something like that. So if that's true, either y plus 3 is equal to 0, so that gives that y is equal to minus 3, or y is equal to 2. So going over here, we've got y is equal to minus 3 or y is equal to 2. But y was sort of my invention. Y was e to the x. So therefore I'm going to say that either e to the x is equal to minus 3. Now that just isn't possible, because if we know the graph of y is equal to e to the x, you know that it's positive for all real values of x. So therefore that case is not possible. Or e to the x is equal to 2. Now in order to solve that, you've got to use this idea that a to the c is equal to b implies that c is log a of b. So applying that to this, we're going to have that x is log to the base e, which we write as ln of 2. So we just have one solution, x is equal to ln of 2. So this has been a video to show you how to solve an exponential equation which leads to a disguised quadratic. I hope you've understood, and I thank you very much for watching.